Hello everyone, welcome to Fluid Statics. So today we're going to be learning about fluids that are simply in static state. In other words, they have no motion. So the first thing that we have to learn is basically the definition of mass density. This is something very simple. You've been doing this throughout your science career, and it's simply, that the density is mass over volume. The only small difference is that now instead of D for density, it's now symbolized with rho. So as you can see on the screen, rho is equal to mass divided by volume. The units now for density is kilograms per meter cubed. If you recall correctly from Physics 1, physics, it is under the MKS system, meaning meters, kilograms, and seconds. So, um, the mass is given in kilograms, and the volume, of course, because it's length, width, and height, each of them is meters. So meter times meter times meter, that's going to be now meters cubed. So here are some representative densities. So on top we have the solids with the highest density, then we have liquids, and finally we have gases with the lowest amount of density. So let's do our first problem. It says, the body of a man whose weight is 690 newtons contains about 5.2 times 10 to the negative 3 meters cubed of blood. So what are they doing here? They are giving us the volume, and they're asking us for weight. So let's go to our trusty sketch pad, and here we go. So we are given right now that the volume, it is 5.2 times 5.2 times 10 to the negative 3. And we're being asked to find the weight. So the weight, as you guys know from Physics 1, is mass times g, which is the acceleration due to gravity. So we know what g is, that's 9.8 meters per second squared, but we don't know what mass is. And they're giving us what the volume is. So what are we going to do? We're going to use the density formula simply because we have the volume, and now we got to find mass. So as you know, rho, which is density, is mass over volume. And when we cross multiply, we see that mass is rho density times volume. And the density for blood, it is 1060 times the volume, which is 5.2 times 10 to the negative 3. And of course, we said that's going to be kilograms per meter cubed. That's going to be meter cubed. So these cross out. So we see that the mass is going to be about 5.5 approximately kilograms. So now that we have the mass, we can simply go into our weight formula and plug it in. So weight now is going to be the mass, which is 5.5 kilograms, times the acceleration due to gravity, which is 9.8 meters per second squared. So we see that that is going to be 5.5 times 9.8. It's about going to be around 54 newtons. And the second part of the question was, of course, to find the overall percentage that the volume has in the body. So we simply take 54 newtons and we divide it by 690, which is the entire basically weight of the body. So going back to our presentation, which is right here. Okay, we see that the mass, just as we calculated, is 5.5 kilograms. And when we multiply it by 9.8, of course, it is 54 newtons. And to find the percentage, we said we take the 54 newtons, that is the weight of the blood, and we divide it by the whole weight of the body times 100, so it's about 7.8%. Now, integral part in physics 2 is going to be specific gravity. So in other words, the way the AP exam is going to give you questions is through specific gravity. So they're not going to give you the density directly, but they will give you the object specific gravity. So what is it? It is simply the ratio of the density of the substance in question to the density of the water at 4 degrees Celsius. So what's the density of water? is a standard number, and it's always going to be 1 times 10 to the third kilograms per meter cubed. This is one of those numbers that please I need you to memorize. And once again, the density of water is going to be 1 times 10 to the third kilograms per meter cubed. So if they give you the specific gravity, the only thing you have to do is take that number that they give you and multiply it by the density of water, and you have the density of the substance in question. We're going to solve a lot more of those problems in class. So continuing, pressure. So basically, what is pressure? Pressure is force that is distributed per given area. The units for pressure is, of course, newtons per meter squared, and that is called 1 Pascal. That is a very small quantity, so we need very, very large quantities in order to describe, pressure. So how does pressure basically originate? It simply originates from the motion of the particles as they collide, as you can see over here, with the sides and the walls of the container. The greater the frequency of collisions, the greater the force that they exert, and therefore the greater the pressure. And the more you spread it out through area, it's going to have an inverse relationship with pressure. So let's solve the following problem. The force on a swimmer. Suppose the pressure acting on the back of a swimmer's hand is 1.2 times 10 to the 5th pascals. The surface area of the back of the hand is 8.4 times 10 to negative 3 meters squared. So they're asking us, A, to determine the magnitude of the force that it acts on it. So they're giving us the pressure and they're giving us the area and asking for force. So let's go back to our trusted sketchbook. Let us clear it out. And we have been given that the pressure is 1.2 times 10 to the 5th pascals, and the area, that was 8.4 times 10 to the negative 3, and that was, of course, meters cubed. So they're asking us now to find what the force is. So we are simply going to take our formula. We said pressure is force divided by area, and we are going to solve now. We cross multiply and we're going to solve for force. So force now becomes pressure times area. So the pressure, we said, is going to be 1.2 times 10 to the 5th pascals, and we're going to multiply by the area, which is 8.4 times 10 to the negative 3. That's going to be meters cubed. I don't have enough space to write it. So the force now becomes 1.2 times 8.4. That's going to be about 10. 10 to the 5th minus 3, 10 to the 2nd, so 10 times 10 to the 2nd. So it's going to be about 1 times 10 to the 3rd, or about 1,000 newtons. And that should be our answer. Going back to our presentation, it's going to be about 1,000 newtons, and we clearly see that once we manipulate the formula for force, we multiply the pressure and we multiply the area, we get it to be 1 times 10 to the 3rd newtons, which is about 1,000 newtons. Thank you very much.